Hi everybody, my name is Fraser Cain and I am the publisher of Universe Today, and this is your weekly space hangout for July 12th, 2012. This week we've got a bunch of stories for you in my text thing. We're going to report on Pluto's new moon, we're going to report on New Horizons doing science in its sleep, the southern polar vortex on Titan, whatever Alan wants to talk about. Pluto! Also wants to talk about Pluto. It's going to be very Pluto special. And we have a very special guest this week. We've got Mark Showalter from the SETI Institute, and you're also involved in the Pluto discovery. So this is going to be a big Pluto week. This is great. I hope Alan Stern is watching. All right, cool. So why don't we get started? So the big news, of course, is the the people here in this hangout. I apologize, man. Focus, Fraser. So we've got Alan Boyle from MSNBC's Cosmic Log. We've got Amy Shira Teitel from Vintage Space. We've got Jason Major from Lights in the Dark. We've got Mike Wall from Space.com, and our special guest this week is Mark Showalter from SETI Institute. And we had Robert Nemiroff from Picture of the Day. Oh, you know what? I don't see you.
I see me. Does anyone else see me?
I see you.
I will just have faith then that Robert Nemiroff is here with us as a disembodied voice in my hangout. We're not having a very technically happy day today. I will apologize in advance for all of the things that are about to go wrong. All right, well, let's get started then. The big news, of course, is Pluto, is the discovery of a new moon on Pluto, and I thought I would have Mike Wall give us the intro on this.
Okay, well, yeah, I mean, I probably shouldn't be saying anything. Mark should probably be the one talking about this stuff because he was really involved with all this. But
sure.
just to sort of give the sort of basics of it. I mean, Pluto now has at least 5 moons. We have learned, because actually yesterday scientists announced that they found another small moon around Pluto. Hubble Space Telescope photos picked it up. It's a little guy. It's about 6 to 15 miles wide, and it's called P5 for now, but that will probably change at some point in the future. And scientists have been scanning this, and just with the Space Telescope Hubble to try to see what all is out there in the system, because actually they've got a spacecraft that's going to fly by Pluto in 2015, and it's called New Horizons spacecraft, and they're a little bit concerned about what the system holds, because that spacecraft is going to be going really fast, and they want to know what kind of debris it might encounter, and if there are more moons, then there's probably more debris out there, because moons actually generate debris when they're struck by other space rocks. And so this is all part of a big campaign to both actually learn about the Pluto system and see what the spacecraft is going to encounter when it gets there. And so it's really exciting. It sort of shows that we really don't know that much about the outer solar system. There's still a lot more to learn. I'm sure Mark could speak more to that. I mean, it's basically there are some other sidelights too. When you say you find another moon around Pluto, then you automatically get people saying, well, if it has 5 moons now, shouldn't it be a planet? Should it have been demoted to dwarf planet? All that stuff. So that's an inevitable sidelight of a discovery like this. But I think that this just shows that, the outer solar system is a very complex and interesting place that we don't know that much about, and we're continuing to learn more and more about it. And it's really interesting that we're learning all this stuff about Pluto, and we're just sort of training instruments on Pluto, but there's so many other objects out there that we haven't been looking at. And so, I mean, there are all sorts of objects out there that might be just as interesting, just as strange as the Pluto system. It's going to take a long time to figure it all out, because these things are so far away, they're so dim, we don't have the manpower or the instruments here to investigate them all in detail. But so that's basically, I mean, the quick and dirty story of P5, and I'll turn it over to Mark or to Alan if they want to talk more about it.
Well, let's definitely get Mark to talk about it. Mark, so what was your role in this discovery?
Yeah, so, well, I am, I guess, the discoverer. I found it on Saturday, so this has been kind of an adventure of the last 5 days or so, getting this all tied up and out there for everybody to know about it. We got data. We've been having this observing program on Hubble. It is just finished. It finished on Monday, in fact. That was our last set of observations. But this was a lot of effort in the planning of it. We looked very closely New Horizons project and the Space Telescope Institute worked very closely to make this all happen. They were very, very generous with their time and their resources to enable us to essentially cherry pick the exact perfect observing opportunities that we would have, and then we essentially put together an observing plan that would be about as sensitive as it could possibly be in searching for small moons and possibly dust rings or the other kinds of things that would potentially be of interest to, and in particular dangerous to, New Horizons, which, by the way, gets there, I think it's the 14th, so 2 days from now it'll be 3 years out from Pluto. At this point, we've got the data all in hand. It's a gorgeous data set. We're very, very excited by it. And it was on Saturday that I was looking at essentially one of the last set of observations we're going to get. And I throw all my data into a big processing algorithm that I have set up in the last year or so that sort of subtracts out the glare of Pluto and removes all the background stars and just does a bunch of things that I figured out how to do in order to see what little dots or little rings might still be left behind. And when I did that on Saturday, this moon, I will say it jumped out. It was not subtle in the data at all. It's quite a bit smaller than P4, which is the moon we found last year, about half as bright, in fact, and it's closer to Pluto, which is why probably we didn't see it last year. It's just that we weren't quite as good at sort of digging out in the noise that's immediately surrounding Pluto. And in all that work, I had a set of 3 images that were each a full Hubble orbit of integration. That's about 35 minutes of data all added together. So we take 3 35-minute exposures, we add them up, and we make a little movie, and there's this dot moving along the screen that caught my eye very quickly, and I was very quickly on the phone with Alan and some other of my coworkers on this project, and yesterday we were able to announce the discovery.
Well, I was muted. That is awesome news. So, I mean, how long would you say you guys had been gathering data on Hubble to find this moon?
Yeah, I mean, I guess the story kind of started last year when I and a colleague, Doug Hamilton, at the University of Maryland. Excuse me, I'm being interrupted by my computer. Let's see. Sorry about that. There we go. Okay, another one of the distractions in this high-tech world we're in.
Well, you know what? Why don't we start again? Because my question was terrible. So why don't we start again? I'll ask a better question, which came to mind. Which is, so did you have any suspicion that there was going to be more moons? Was this just a hunch, or did you just book time on the Hubble telescope and just search for moons because there's probably more because they've already found 4?
It's kind of both of those things. I mean, honestly, what came out of last year's discovery was this recognition, and we probably should have had it sooner, that we really don't know very much about Pluto, and this spacecraft is going to pass through the system at 15 kilometers per second. Luckily, they planned ahead, and they covered this thing with Kevlar. Basically, it's got a bulletproof covering, and that means we could hit something. A dust mote wouldn't be a hazard to the spacecraft, but something the size of a BB, for example, could be completely lethal to the spacecraft. And if you kill New Horizons when it gets to Pluto, you lose everything because it's saving all the data on board and shipping it down afterwards. So it's not like we would get half the data if it made it to Pluto and then died. We would lose everything. So realizing that we didn't know as much about the system as we should, we worked with the Space Telescope Institute to get, as I said, this really beautiful set of data that is designed in part to look for small moons and for dust rings. The idea with a small moon is that you're not going to hit a moon. It's very, very unlikely. But these small moons often have dust rings around them. So anything like that that's in very close to the planet is where we're most concerned. The object we found is a fair distance outside the sort of core Charon Pluto system, and so we won't really need to worry about that as an impact hazard. But it's nice to know it's there. So finding new science targets is a fringe benefit of a project that is really devoted toward understanding what kind of danger New Horizons is in. New Horizons does have a last opportunity this year to plan an alternative trajectory. They've got a target point that is basically near Pluto on the opposite side from Charon, and that's the scientifically optimal location, and that's where we want to go. But if there's anything at all remotely dangerous about that location, we can decide even 10 days before we get to Pluto to jump to a different target point, but we have to plan that target point this year. So we want to know what's there, and that's what we're looking for.
Right, and so the real objective here is that you might not be able to see objects that you're going to impact with, but a small moon might be carrying a lot of debris in its region, and it sort of designates an area that you would really want to avoid. So,
right.
So there's a real value to this. Are you done sort of observations between now and when New Horizons is going to be reaching Pluto? Is there going to be a point where you can no longer make observations that will make any kind of impact because it's too late to turn the trajectory of the spacecraft? Right. Yeah, change it without having any kind of collision,
scientific, yes.
Any kind of explosion?
Well, so the best opportunities for observing Pluto come around once a year, around June, because that's when Pluto is at opposition, Sun, Earth, Pluto being roughly aligned at that point. So we do not have any more observations planned this year. We could always propose and maybe get some more time next year. And as a scientific target now, Pluto remains exceedingly interesting, and we will certainly want to get some more data as scientists. But the data that we will use to assess the hazard, the threat to the New Horizons spacecraft is all on the ground now. This is what we've got to work with, and we'll be working with that over the next month or two to figure out what exactly it says. If there is a P6 or a P7, I would think in the next month or two you'll be hearing about them. They'll be presumably a bit smaller than P4 and P5 at this point, but there could be little blips out there, and we just can't say they're not there yet. So that's part of our study. Any rings, of course, we'll also be looking for.
Well, feel free to announce any of those right now if you like. We'd be glad to help get the word out for you right now if you've discovered P6 and P7. That's what you're.
Sorry, I can't. I say, but in fact there isn't. Anyway.
Yeah, no, I understand. I understand how this works. Don't worry, it's just us and our few hundred friends. Okay, great. Well, that's fantastic news, and thank you very much. Now, I've got a few questions. I'm not sure what your time is like. I know you're busy right now. So what I thought normally we would sort of wait to the end and take in some questions from the viewers, but I think right now, we'll get as many questions as we can and sort of wrap this phase up, and then you're free to move on with your work and finding more moons and rings. So a couple of questions for you.
Yeah.
Jeff Borstel wants to know, why is the New Horizons data coming in like you described, all at once rather than live, and how will it be received?
Well, it comes in essentially when you do Hubble observations, you can retrieve them from the archive usually a few hours later. So the data that I was looking at on Saturday afternoon had actually executed on the spacecraft Saturday morning. And the reason things are bunched together is just because this is the best season of the year for observing Pluto. It's because Pluto is at its best location in the sky for doing the work that we're doing.
And I mean, people don't realize, the distance to Pluto is so far, it takes so long for the communications to come. You can't just fly it like a video game. It's
Well, we're talking two things. The spacecraft you can't fly in real time.
But the data coming back from it, yeah.
Yeah, but the Hubble observations, we still had that sort of canned and in the bag, ready to execute a few months ago. Everything has to be stacked up, and they have a lead time that's required. So we had planned these observations back a few months ago. Now we're getting the fruit of that work.
I think Jeff was wondering why it is that you store the data during the Pluto flyby and then send it back later. Why don't you send it in real time?
Oh, that's because this is a spacecraft with no moving parts. And so if you want to gather science, you cannot point your antenna at the Earth at the same time that you're doing that. You just don't have the rotational flexibility that is required. And that was part of how they made the spacecraft very light and able to get to Pluto in such a short period of time. It was launched, I believe, in 2006, I think. And so getting there in just these 6 years or so is pretty remarkable.
Yeah, it's kind of amazing to think about the fact that we're only just a few years away now. It feels like I've been reporting on this for my whole professional career.
Yeah, 3 years is not a long time.
No, I know. This isn't a question, but Eli Mendez notes that it's too bad that New Horizons won't be going into orbit.
Yes.
And maybe I think we all understand why, which is because to get there in a short amount of time, you have to go tremendously fast and zip right past.
Right.
But do you think it would be possible down the road to send an orbiter?
Orbiters are tricky. The reason has to do with, getting to a planet. Well, that's part of the job. If you're going to stay in orbit, then you have to stop. So the laws of mechanics say you get there at, you're moving 15 kilometers per second, and if you don't do anything, you'll just sail on past. So what we're doing is, to get an orbit around Pluto would be to show up at Pluto moving at about 15 kilometers a second, and then slow down to something really very slow, because Pluto is not a very massive planet, and the orbits around it are very slow. So that takes a lot of retro rockets. It takes a lot of fuel propellant of some sort. If you look at what Cassini did at Saturn, or what Juno is about to do at Jupiter, these things have very, very big rocket engines and lots of fuel on them. And the very first thing they do when they get to the planet is turn around backwards and jam on the brakes, in effect, by firing retro rockets to slow yourself down so that you end up in orbit. That takes a lot of effort.
Well, it's wonderful news, Mark, and we really appreciate you taking the time to jump into this weekly Space Hangout. It's tremendous, so a tremendous accomplishment, and I look forward to the announcements of P6, P7, and the rings.
I'll do what I can.
That's fantastic. Well, you're free to go. You can stick around if you want. And we'll take any more Pluto questions. I know Alan and Mike know quite a bit about this as well. So thank you very much.
Okay, it was great talking to you. Thanks a lot.
Thanks, Mark.
All right. Well, okay, so then why don't we move on then. Now, Amy, you had some related news, which is about New Horizons doing science in its sleep.
Yeah, so we've just been talking about New Horizons a little bit, the spacecraft on its way to Pluto. And it's doing some pretty interesting stuff right now. It's in hibernation because, like you said, it's about 3 years away from the planet, and there's not much for it to do in the meantime. So it was designed to leave one instrument on during its period of hibernation, the student dust counter, which is designed to allow the spacecraft to collect data on dust in interplanetary space by measuring impacts as it flies through the solar system's dust disk. But that seemed to the program scientists like a bit of a waste. It's kind of fascinating to have this spacecraft way out there. It's been 3 decades since we've had an active spacecraft in this area, sort of past Saturn and before Pluto. And we have all this data from Pioneers 10 and 11 and Voyagers 1 and 2. So the team started wondering, what else could we leave on? What else could we be doing with New Horizons while it's in hibernation? So there are 2 other, Alan Stern, of course, is behind this initiative to get as much science out of this mission as possible. Started looking at the possibility of leaving on other instruments during the hibernation period. His picks were the Solar Wind Around Pluto instrument and the Pluto Energetic Particle Spectrometer Science Investigation instrument, which has the great acronym PEPSI. So both SWAP and PEPSI, as they're known, measure charged particles of radiation environment along the spacecraft's trajectory. They sample solar wind protons as they travel away from the sun. They pick up ions that are created by solar wind protons and solar photons interacting with hydrogen, and measure ions heavier than helium and ions traveling faster than the solar wind. So the possibility of getting all these this interesting solar science from way out between Saturn and Pluto was pretty interesting, but then it became a question of, okay, well, can we do this without ruining everything? Of course, this is going to draw off the spacecraft's power. It's going to, is the dust collector going to interfere with these, or are they going to interfere with the dust collector? Because the idea is to, not sacrifice one for the other, but to get more in general. So the team ran a whole bunch of tests, ground tests, 3 multi-day 3-instrument tests while the spacecraft was in hibernation last October, and then some enhanced hibernation cruise tests in January and April, and finally decided that yes, all these things can actually run in hibernation at the same time without interfering with each other, interfering with the spacecraft. And on July 6th, when they shut the spacecraft down, they left these 3 instruments running. So now we're not only getting really interesting information about the dust disk in the solar system, we're getting a lot of really neat solar measurements that can be added to and sort of complemented by the Voyager and the Pioneer data. So that's pretty neat. I would love to do science in my sleep.
Yeah, exactly.
This is amazingly efficient. Actually, Alan Stern said that it's called it a real success story for low-cost outer planetary missions. And it's really interesting to be able to sort of squeeze this much after launch, just kind of add this idea into a mission.
I find that you can pretty much guarantee on any mission that they're going to end up using that spacecraft for things that they never intended.
Yeah.
So, yeah, and so this is a classic example. Yeah, you've got the hardware there; it's already out in space. It's just a matter of coming up with some ideas for it. So,
yeah.
Now, Alan, you had some additional stuff on Pluto that you wanted to mention.
Oh, yeah. First of all, I got this book here. So I wrote a book a couple of years ago, The Case for Pluto, and so if anyone is really interested in that, that's my one advertisement of the day. But one of the questions that came up is, why is it that Pluto has all these moons, and have they found moons? Are there going to be more moons to find? And the interesting thing about this is, as Mark could tell you, is that they're finding moons at particular resonances in relation to Sharon. So there's a really complicated ballet going on here, and that's why all these moons have been able to survive, is because the mechanics are set up so that they stay out of each other's way. For example, there's a 1 to 4 resonance and 1 to 5 resonance. That means that in the time that it takes Sharon to make one orbit, these other orbits make 4 or 5 almost exactly, and that way they're able to kind of stay very stable. And so the interesting thing is that there are a couple of these resonances that they haven't looked at yet. For example, 1 to 2 or 1 to 7. And so when Mark and his colleagues look at the data from Hubble, I'm betting that they're going to pay special attention to those particular areas. But it's a very difficult observation to make, because you're looking at something that is like the separation is the breadth of a hair as seen from yards and yards away. So it's a very tough, and there may be things there that they just can't detect.
Alan, I think one of the analogies that was used was that these moons are kind of like a set of Russian nesting dolls.
Exactly.
All in their perfect spots, progressively larger orbits.
Yeah, exactly. So it's very finely tuned, and that's why they think that these moons were created when a couple of big things slammed into each other and resulted in all this debris that eventually coalesced into Pluto and Sharon as we know it. And then these other bits are areas of debris that coalesced at these particular resonance points. And so these moons are probably very, very old. It's not like they're latecomers to the party. They've been around for a long time. And so it illustrates that even though Pluto is a dwarf planet and it doesn't get much respect nowadays, it can keep things in line pretty well. So I still don't think you shouldn't underestimate the little guy. And so that's what I wanted to say on Pluto. And there was something else that came up this week. There's a big air show in England, the Farnborough Air Show, and there was some announcements made related to Virgin Galactic, which is aiming to put tourists into space. And the big news this week is that they're also aiming to put rockets into space, that the carrier airplane known as the White Knight 2 can be used to drop rockets and have them launch payloads into space, starting in the 2015 to 2016 timeframe. And one of the clients is going to be another one that we've talked about here on the Space Hangout, is Planetary Resources, which wants to put these space telescopes into Earth orbit to look around for near-Earth asteroids that would be worth mining. And so you've got this grand convergence of all these weird, far-out space ideas to turn them into reality. And it's really interesting to see that. So I wanted to touch on that as well.
Now, is there anything that's kind of interesting and clever about this launcher? I mean, that's different from it's not a big rocket, is it? It's something else.
It's actually, as opposed to Spaceship 2, which is going to be the tourist craft, this is more of a conventional rocket, kerosene-powered, air-launched. A lot of other people are talking about air launch. In fact, there's another venture that billionaire Paul Allen is backing. If you remember, it's a Stratolauncher, which does a similar thing. It's a huge plane that the same folks who are building things for Virgin Galactic are building for the Stratolauncher venture, and they'll be launching a modified version of a Falcon, SpaceX Falcon rocket. So you're starting to see some competition in that space, and some familiar names are popping up in unfamiliar environments.
Now, have you seen is it the Skylon? I think it's a
Skylon, yeah.
Yeah, it's
another
an English.
concept.
Yeah, it's an English. I think it's from England, and it's a sort of air-breathing aircraft, and then it reaches a certain point, and then it switches to a sort of rocket engine propelled. So it flies up into the air, gets to a certain altitude, and then the rockets kick in, and it actually takes itself out into orbit. So I love it. It's a I watch the animations and just drool, and I just think that would just be amazing if that would actually get built. So
yeah, that's one of the coolest looking spaceships that you'd ever see.
It looks like it's from the future. It looks like a proper rocket ship, like that's the kind of thing that people would be hurtling through the cosmos, exploring other worlds. So yeah.
Yeah, we just went past the 8th anniversary of the Spaceship One first flight into space, and at that time people were talking that the future of space travel was just 2 years away, and lo and behold, 8 years later, it's still 2 years away. So
it's starting to follow fusion powers sort of course, isn't it? That it's always 30 years away. Yeah, I didn't realize that. It's kind of dangerous. So we've brought in I guess, a special guest for another time, which is Robert Nemiroff from Astronomy Picture of the Day, and Robert was going to show off a bunch of photographs that have been featured in Astronomy Picture of the Day in the last couple of days, which is great. Now, if you've never seen Astronomy Picture of the Day, you can find it. Let's do a search for APOD, apod.nasa.gov. Yeah.
That's right, apod.nasa.gov.
Yeah.
So I was on this show, seems like maybe a month or so ago,
Yeah.
so there have been a lot of interesting pictures since then. So one I wanted to go to, a little iPad here, is June 26, 2012. So in this past month, we've passed the summer solstice for the Northern Hemisphere, and so we had our longest amount of daylight in 24 hours. And so it looks like this.
Let me see if I can get it for you.
There's some reflections there.
Unfortunately,
and what that is a sundial that is on a campus in France. And what's cool about this sundial is that it actually lights up with the word solstice on the summer solstice. And so it really looks futuristic, too. So it's a cool-looking device. And one of the reasons why I like it is because many people own sundials, and this is a way that people can participate in space and astronomy even during the day. You can get a sundial, or you can look outside for something that can just be a sundial, because anything is really a sundial. And so I thought it was really cool that this thing lit up with solstice. And so now I'm thinking that maybe we should get something like this for our campus at Michigan Technological University in northern Michigan. So that was an image on June 26th. You can see that futuristic-looking device. I don't think, after thinking about it, I don't think it has to be so futuristic to actually show up with the word solstice. You can do it more simply, but this thing probably lights up with, well, I know it lights up with the word equinox at, surprisingly, the equinox. So that was a pretty cool submission that we got. So we couldn't run it on the solstice because we would only submit it afterwards. Let's see. Another one I'd like to go to is, okay, let's jump to July 3rd, 2012, and there's a picture of Saturn and Titan on a string. Oh, Jason went away. Oh,
okay, I can do it. What date was it?
I was I was going to ask him about it. This is a setup for Jason. So it's July 3rd, 2012. So it's a really cool picture of Saturn and Titan, and taken from Cassini, which is orbiting Saturn, like, as we speak, surprisingly enough.
And Jason colored it, right?
Yeah, so I didn't know that. So I got this from the European Space Agency's page, thinking, oh, this is great, but isn't it odd that it didn't appear on the Cassini's page or in JPL's page? But they picked it up from Jason, who colored it. So it's this is something also that people want to play at home. You can take images that come in black and white, and there's lots more images that come in black and white than in color, and you can impose a realistic-looking color table. And we're actually in a weekly space hangout, and Emily Lakdawala taught us all how to do this. Okay.
And
so cool.
Jason actually did one of these in real time during the hangout while Emily was explaining where to get your data and how to sort of process them together, and he's gotten really good at doing these color images.
Another two cool things about this image, you can see again how thin Saturn's rings are, which is a common student misconception that they're somehow quite thick, but these things are really razor thin. You can see Titan orbits in the same plane as the rings. You can see the rings are more than so thin because you can see the black stuff in the southern hemisphere is the shadow of the rings, so the sun is out there. And then at the top, there's a surprise. At the top, you can see a white band of clouds, and that white band of clouds is actually broken up a bit and has been studied by the Cassini team because it tells them about the jet stream of higher clouds on Saturn. So this is a beautiful image that has a lot of angles to it, and so we were happy to run this. It was actually a very deep image. And so let's see, the last one I guess I'll go to is the controversial one, because it appears to be many people in astronomy. On July 10, 2012, we had something that always is going to generate a lot of feedback. Some of it negative is that we had Matt Harding's video on what we titled Happy People Dancing on Planet Earth. So this has been an internet phenomena for his previous videos, and so I really like it. And also, I sometimes look to create an APOD out of, if we need a keyword linked, and I don't know of a good link, then sometimes I'll try to make something an APOD that I can then link to. So I didn't have a good link for the word people. So when I saw this, I thought, not only was this cool, not only does this really, if you had to summarize people on planet Earth with like one image or video, this might not be a bad one, but here's something I could link to the word people in future things, and it would be something that would be cool. So here we have a video that runs, I don't know, a couple of minutes. It's a dance video, it's a music video. It seems to bring together the people of Earth. It just has this unified people of Earth spirit to it. But we get lots of, there we go, I can see it on Fraser's. We get lots of people who say, why, this isn't astronomy, this isn't, astronomy is not a picture, what are you doing, cancel my subscription immediately. But we do know that this doesn't hurt our page views much. In fact, generally it helps it because there's people who wouldn't normally have known this, about this, who see it and who are brought into our little thing. So it's, I don't know if you want to play it with the music, but it runs for a few minutes.
I don't think I can, but yeah, okay. It's about 5 minutes, so.
Yeah, so it's probably not. But I advise you can find it all over the internet. It's got now millions of views, so you can find it with us as well. And so I don't want to play piggy with time here, so we'll just go with those three images today. Thanks for the opportunity to speak about it.
And you got some grumpy attitude from people?
Yeah, so we have a discussion board, and maybe half the images were, why are you doing this? Cancel my subscription immediately.
I want my refund.
Yeah, send me back some money because this isn't fair. So, but we're not forcing them to look there, and they don't have to pay money. So every now and then we go off a little bit off topic, but I think not so much off topic with this one.
How dare you?
Yeah. So, but it's fun. I just love these videos.
Oh, that's great. No, it's totally fine. Mm-hmm. I totally approve. of doing it. Now,
Hey, Fraser?
now, Alan, yeah, you had something else you
when I was talking about Sharon and these resonances with Pluto, Jorge Candeas pointed out that it's actually, I had the situation reversed. And so if anyone's watching this for their term paper, it's actually Sharon going around internally, and then the others taking a one turn around as Sharon takes multiple turns around. So if you look at the YouTube piece that's linked from the comments, you'll get a better idea of how this all works together.
Now, we've got a couple of questions I thought we would run through, and I think this is a good one for you, Mike. Eli Mendes says, is it just me, or is the space industry the next dot-com boom? So what do you think? Do you think we're in a dot-com boom style investment bubble in the space industry?
Well, I don't know. I mean, I think a lot of people are asking that question. I mean, everybody is waiting to see, I mean, is this stuff really all that viable? Is there a lot of money to be made? Certainly a lot of people with deep pockets think there's money to be made, which, yeah, I don't know, argues pretty strongly that there's something there. But yeah, people are waiting to see, I mean, Virgin Galactic, is it going to be able to actually sustain that business model? Are there going to be more than 550 people who want to pay 200 grand to go to suborbital space? Like, are they going to be able to lower their prices to actually make it more accessible to more people? Yeah, people are really looking very carefully at these companies. I mean, SpaceX, it was a huge deal that they were able to dock with the space station just a couple of months ago, because that really shows that, wow, I mean, this is something that had only been done by big, billion-dollar government agency efforts, and here's a company that's coming along and doing it. Yeah, I mean, I don't know. I mean, I think it'll be really interesting to come back in 5 years and see what all this stuff has led to, but it's still up in the air, so to speak. And I think that, yeah, people have been talking about new space and private space flight for years. Like again, Alan pointed out, I mean, it's been 8 years since Spaceship One went up, and everybody was talking then about it's just around the corner. And it seems like it's always just around the corner, but it seems like now we are seeing a little bit more real momentum building up. So I don't know. I mean, I'll have to wait and see.
And I wonder what the crash would look like on the other side if it does, all this infrastructure gets built out, and then it's not the same as technology. So,
yeah,
I don't know.
Well, what's interesting too is some of this stuff is multi-decade efforts. I mean, you talk about all these asteroid mining projects. Planetary Resources, Alan was talking about. They're just getting set to launch some of their spotting scopes basically to see what would make good mining targets, and they're not going to be able to actually bring any of the resources back after they mine them for decades probably. So this is not a conversation that we'll be able to really have for, I don't know, 20 years to see if some of this stuff actually pans out. It's really long-term stuff.
Yeah, so it would really be a bubble unfolding in very slow motion.
Right.
And one of the books I'm reading is 1493 that goes into what happened after Columbus came to the New World. And the book traces how a lot of these joint stock companies that were formed to settle the New World really went out of business and lost a lot of money. And so it might be that sort of model where you have a lot of failures before somebody gets that Jamestown settlement going on a near-Earth asteroid.
Yeah. All right. Well, I think we apologize to everybody for all of the issues that we had to starting up the show today. Google Plus was not our friend today, but and thanks again to Mark for showing up and reporting on the actual discovery. What a treat to have one of the discoverers of the Pluto moon actually here joining us in the Weekly Space Hangout. And apologies, well, Jason had to go, so we didn't get his story. So I think we'll just start to wrap things up. So before we do, I want to make sure that people know.
Can I ask one question before we go?
Absolutely.
I just wanted to get the sort of group's opinion on this, because you mentioned earlier that all of Pluto's new moons is probably going to spark some kind of controversy with the Pluto lovers or Pluto haters. What do you guys who are sort of ensconced in this, what do you think the reaction from the public is going to be that this new moon, should it enhance the status? I mean, I'm asking this rhetorically. I know this doesn't actually change things, but I feel like there could be a really interesting fallout. Just wondering
Yeah, every time there's a revelation about Pluto, whether it's, there's carbon monoxide in its atmosphere, or it has weather, or it has new moons, you get that interest. People still feel kind of protective toward the little guy. You're right that it doesn't really reflect the status, that asteroids can have moons too. The number, if Pluto had 6 or 16 moons, it wouldn't make any difference. But it does illustrate that whether you call it a dwarf planet or a real planet like Pinocchio was a real boy, Pluto and other things that are out there in the Kuiper Belt are definitely more interesting than people thought, and they're getting more interesting every year. So yes, there will be talk about, well, doesn't this make Pluto a planet? And I think if you think of it as a dwarf planet, that's good enough, that people realize that it's a special sort of object. And I don't think that there's going to be any revisiting of the decision, but I don't think people are going to forget about Pluto or the other dwarf planets either, for sure.
But you believe. I could see, I love the poster in your background there, Alan.
The designation comes from the International Astronomical Union, which I think meets in August of this year again. And I was surprised last time when they demoted it. I don't know what's on the agenda for this. It's in China in August. It's possible, from what I know, that they could vote Pluto into planet status again. But we won't know until August.
Yeah. All right. Well, now I think I'll wrap it up. So before I do, though, I want to just give one last plug to Mark Showalter, and you can actually you can circle him. You can see his name is one of the participants in this Hangout. But another place we're going to get more information is from the SETI Institute page. So you can just do a search on Google Plus for SETI Institute, and you'll find their page, and you can follow them. And there's going to be a lot of really interesting news coming out from them. So I just wanted to give that a plug. Alan, Boyle, where do we find more about you?
CosmicLog.com or space.msnbc.com.
Perfect. And Amy, where do we find more about you?
AmyShiraTeitel.com and Google Plus.
And Mike Wall?
Just go to space.com and read the stories that we post every day.
You're producing an awful lot of them.
Yeah, well, there's a lot going on.
I know the feeling. Great, and then and Robert Nemiroff, where can we find out more?
apod.nasa.gov.
And if a person has a beautiful photograph that they want to contribute to APOD, how do they do it?
Look for email addresses there.
Okay, there's information on the website. That makes sense. Great. Well, thank you to everybody who joined us. Thanks to everyone watching. Sorry for the technical difficulties today. We should get this. Well, they'll probably be here next week too. So thanks everybody. We will see you all next week. Talk to you later.
All right. See you guys.
Bye.